I'm Josh Freed, Senior Vice President for Climate and Energy at Third Way, a multi-issue think tank based in Washington, D.C. We'd like to welcome you to our event on the role of nuclear energy in decarbonizing industrial heat, coordinated by TerraPraxis and the Nuclear Innovation Clean Energy Future. Today's event is part of the second year of NICE Future's Flexible Nuclear Campaign for Nuclear Renewables Integration here at the Clean Energy Ministerial. Our objective is to examine the challenges and opportunities in accelerating transitions to net zero emissions energy systems. The next decade may prove to be the most critical to our ability to reach emissions reduction goals. Heavy industry, aviation, and other sectors still lack clean energy solutions, putting us at risk of missing our climate targets. Reaching net zero will necessitate identifying and deploying practical and easily adaptable policy solutions in these sectors. In just a moment, you'll hear a discussion about how we can decarbonize industrial heat applications for steel, cement, shipping, and other sectors using both existing industrial capabilities, hydrogen-based fuels, and next-generation advanced reactors. You will hear from policymakers who are seeking cohesive, cost-effective solutions for their constituents, researchers finding pathways to decarbonizing the economy, and technology providers who are working to deliver the solutions to meet our needs and goals. If the last year has taught us anything about addressing a crisis, it's that we must acknowledge the science and work together toward a common goal of reaching our desired results. We hope you enjoy the discussion today.
Hello, everyone, and welcome to this Clean Energy Ministerial Side event. The topic is nuclear heat for decarbonization of hard-to-abate sectors. My name is Chada. I am the Chief Executive of Top Tier Impact Strategies, and I have the honor to be your moderator for this event and this incredible session we are holding today. It's now my pleasure to introduce the UK Minister Rachel Maclean, who is the Parliamentary Under-Secretary of State at the Department of Transport.
Thank you to TerraPraxis for inviting me to say a few words. We have entered a decisive decade in our battle to reduce global warming, and the UK's sixth carbon budget is a significant step in the right direction. We've pledged a 78% reduction in carbon emissions by 2035, and we have included international aviation and shipping within that target. So as the UK prepares to host COP26 later this year, I hope this underlines our commitment to this global effort. I urge other countries to be similarly ambitious. Now, hydrogen-derived fuels and other synthetic fuels will play a vital role in reducing emissions, particularly in maritime and aviation. They also present an economic opportunity, with the size of the green aviation market alone set to be worth trillions of dollars more widely by 2050. But there remain barriers to the commercial deployment of sustainable aviation fuels and clean maritime technologies. That's why the UK government recently launched a £20 million Clean Maritime Demonstration competition to fund feasibility studies and trials in green and smart shipping and enable cleaner, greener ports. This builds on our Clean Maritime Plan, our strategy to achieve net zero in the shipping sector by 2050. Meanwhile, in aviation, we've launched a £15 million Green Fuels, Green Skies competition, supporting the early development of UK-based sustainable aviation fuel projects, including synthetic fuels. And the Jet Zero Council, a body bringing together government, industry and academia, will aim to send the first zero-emission passenger flight across the Atlantic within a generation. We will be bringing all these ambitions, targets and measures under one transport decarbonisation plan, which will be published later this spring, covering all modes of transport from shipping to HGVs, The plan will provide a pathway to delivering transport's contribution to net zero. Of course, the UK can't do this alone. This is a global emergency requiring international cooperation, and nowhere more so than in the aviation and maritime sectors. So the UK's presidency of COP26 provides an opportunity to showcase the progress we've made and to learn from other nations. In Glasgow, we'll highlight developments across electrification, hydrogen-powered flight and sustainable aviation fuels. And the UK will also bring forward proposals to accelerate the decarbonisation of international shipping and aviation, working closely with our partners, the International Maritime Organisation and the International Civil Aviation Organisation. To finish, let me reiterate that the UK is ready to help lead the global effort in the development and deployment of alternative fuels across aviation and shipping. And we're committed to working with industry and international partners in not just tackling the urgent problem of climate change, but also creating a more sustainable and prosperous economy for all.
Thank you very much, Minister. Now, I would like to introduce Nobuo Tanaka. Tanaka-san is the chair of Steering Committee of Innovation for Cool Earth Forum, and he is the previous or former executive director of the IEA, which is the International Energy Agency.
Okay, my subject today is the hydrogen, golden age of hydrogen coming. The Fatih Bill said that the COVID-19 makes the energy market hit very, very substantially. Especially the oil market is collapsed, while renewables is moving ahead. And he is getting more optimistic about the future. One reason is the COVID-19 accelerate the transformation. There are 123 more countries are now announcing carbon neutral by 2050. And renewable is getting very cheap, especially solar and wind, and they are the new king of electricity. But the problem is not solved by only renewables. It's the existing energy infrastructure is too big to ignore. The coal, steel, cement, and heavy trucks. And many of them takes really long term to deplete. And the issue is for the emerging Asia. Developing economy needs this infrastructure for economic growth. How to decarbonize these very hard to abate sectors. Japan started with fuel cell motor vehicle like Mirai since 2014. But we focused too much on the mobility, and China and EU overtook us. After Prime Minister Suga's announcement of carbon neutrality last year, Japan has changing very dramatically toward that direction. And METI announced green growth strategy, and hydrogen is everywhere. Small modular reactor, but also nuclear can be used to generate hydrogen. And I think this is a manifest for Japan returning to the hydrogen leadership. And trading hydrogen is another important element, which Japan started LNG, liquid natural gas trading 50 years ago. But now we must move toward trading hydrogen, either in ammonia or liquefied hydrogen or organic hydrate. ICEF, which was created 2014 by former Prime Minister Abe, is an international format of promoting innovation for sustainability. IEA, in a sustainable recovery plan, identified 4 major technologies which is necessary: hydrogen, batteries, CCUS, and small modular reactor. ICEF cannot agree more. And for the nuclear power, important thing is this flexibility. Jill Angel Cox came to ICEF and presented a case. After Fukushima, to recover the public concern, support to the nuclear power, we need passive safety, we need solution for the high-level waste, and easy collaboration with renewables in a very much decentralized manner. Last but not least, important issue is general gender balance. I think the women is much more friendlier to the environment. And those companies with heavy women's board has a better decision and performance in climate change. So final message from ICEF last year was that there are important technology like battery, hydrogen, SMR, CCUS, carbon recycle, but players, major players should be women to reach beyond zero emission reduction toward 2050. And thank you for my opportunity to make a presentation about ICEF.
Thanks very much, Tanaka-san. That was brilliant. Now it's my pleasure to invite Dr. Irvin Plett. And may I say how much I envy your title, Dr. Plett, who is the Green Hydrogen Ambassador appointed by the Chilean Minister for Energy. Dr. Plett, the floor is yours. Thank you.
First of all, welcome you here in Chile. We are very proud to host the Clean Energy Ministerial Meeting and also Mission Innovation 6. So we are very proud to have you here. First, I just want to borrow this slide from the International Energy Organization just to show you what are we talking about here. We do have about 70 million tons a year of hydrogen that we're producing, and as a byproduct, other 48. So our total business of hydrogen, you see, is about 100 and about 117. So if we multiply just by $2 a kilogram, we are talking about a business of 250 billions. Okay, one part of this hydrogen is used to produce ammonia, and that is a key element for decarbonizing, for instance, shipping. So we take about the 31 million tons of hydrogen and produce about 180 million tons of ammonia. That's about 500,000 a day, just to have an order of magnitude. What about the prices in hydrogen? I borrowed this from Bloomberg, Nef, and you see that depending on our gray hydrogen that we're producing, we could have carbon capture, and those are about 50 cents or 60 cents on top of the price. Now, what we want to do in Chile, we do have the resources to have a very cheap hydrogen, and we are aiming to $1.50 a kilogram. That is our aim, because we do have their natural resources for that. Chile is blessed by a lot of sun. And just to remind the audience, our sun, which is our nuclear reactor, fusion reactor, which is 150 million kilometers, we do have one for free, and giving us about 10,000 times the energy we need in the whole world. So we do have a lot of sun, wind, which is also a consequence of that. So how much can we harvest? In Chile, you see we have a solar PV, solar concentration plants, and we do have about, our potential in renewables about 2 terawatt. 2 terawatt is a lot. Just to remind you, the whole world uses about 16 terawatt if we would have constant power. So this is 75 times the installed capacity, electric capacity in Chile. So we do have a lot to share with the world. 2017, there was a nice article from the Washington Post. They were, of course, battling against a former American president who said he had the cleanest carbon in the world, and said, look what Chile is doing. Okay, and they say if Chile is a next solar Saudi Arabia. And we did 2 publications, one with Hans Kuhlenkampf and one in Fertilizer Focus, and we compared what is coming out of Saudi Arabia today, average 2.7 billion barrels of crude. If we just burn that, we will have 16 exajoule. By the way, all the world, what the energy we need in the world is 500 exajoule, okay? And if we do electricity out of that, you see, we will lose a lot at 1/3. So this is the amount of electricity Saudi Arabia is exporting. If I compare the potential, the 2 terawatt, which I show you, with the plant factor, which is different for the different technologies, we have about 6 petawatt hours. Converted to hydrogen with today's technology, we'll have 2 100 million tons. So this is about 3 times the hydrogen produced today in the whole world. If we burn that hydrogen, we will have 22 exajoules. So we are in the order of magnitude of Saudi Arabia. But if we do electricity with just today's fuel cells, which is 55% efficiency, we will double the amount of electricity as coming out of Saudi Arabia. If we convert this to ammonia, we could produce about 1,100 million tons. Just to remind you, today we produce 180 worldwide. So we do, this is 6-fold the amount of ammonia coming out of all plants in the world. Shipping will use about 1 million tons a year. So with 360, we could cover whole range of shipping. So we could decarbonize complete shipping just coming out of Chile. That is our tremendous challenge. So in the National Green Hydrogen Strategy, we have our ambition to have 5 gigawatt installed in 5 years. And in 10 years, we want to go to 25 gigawatts. This is quite a lot. And we want to be the cheapest hydrogen on the planet just by using our solar resources. I would like to, this short presentation, just thank you for visiting us. And we are very proud to have you here discussing this decarbonization of these hard-to-abate sectors.
Thank you very much, Dr. Pleth. That was great. It's great to see that Chile is blessed with such remarkable abundance of solar and wind. And obviously there are many countries who don't have these. So what are the other alternatives out there? So on that note, I would like to introduce Seth Gray. Seth is the president and CEO of the Lightbridge Corporation. Seth, the floor is yours. Thank you.
Thank you, Anj. And thank you to Nice Future and Terra Praxis for inviting me. When you look at some news articles, you may get the impression that we are making serious progress on decarbonizing our economy. We have some progress in the electricity sector, reducing emissions in some countries as we have switched from coal plants to natural gas plants. Reduced economic activity from the COVID-19 pandemic has also tamped down emissions. But these effects are like being on a sugar high, from which we are going to come down hard as we move on from electricity to sectors that are more difficult to decarbonize. For some sectors, such as aviation, shipping, and transportation, we have done relatively little to reduce emissions. The same is true for cement and steel production. Nearly all of the power to drive these sectors comes from fossil fuels. As we look to sources to replace these fossil fuels, nuclear energy has many advantages beyond preventing carbon emissions. Nuclear energy runs 24/7 and has immense energy density and a small environmental footprint. In short, if we are going to succeed in decarbonizing across all sectors of our economy, nuclear must be a major part of the solution. For some applications, we can use nuclear energy as a straight replacement for burning fossil fuels. For others, we can employ more complex solutions. For example, we can use high temperature heat produced by reactors to separate hydrogen from oxygen, producing pure hydrogen for zero carbon liquid fuels and fuel cells in these difficult to decarbonize sectors. High temperature steam electrolysis is more efficient than room temperature electrolysis. This process can be done at low cost because the electrolysis reaction is more efficient at higher temperatures, which can economically be produced by reactors. As the cost of producing hydrogen falls, as advanced nuclear reactors and fuels are developed, hydrogen can also be used to produce industrial heat. This is very important because industrial heat makes up 2/3 of industrial energy demand and almost 1/5 of global energy consumption. It also constitutes most of the direct industrial CO2 emitted each year. as most industrial heat originates from fossil fuel combustion. Industries use heat for a wide variety of applications, including washing, sterilizing, cooking, drying, preheating of boiler feed water, and much more. In order to produce clean energy, nuclear is scalable, so it can expand to the enormous size of the challenge we face. The scale of this problem is truly enormous, and the clock is running. We have less than 30 years until 2050. That is less time than the duration of a standard mortgage on a house in the United States. So the time to start is now. Thank you. I look forward to the discussion.
Seth, thank you very much. Next, I would like to introduce and invite Kirsty Goodwin, who is the founder of TerraPraxis and co-author of a very interesting report which digs deep into how hydrogen-enabled synthetic fuels can help deliver the Paris goals. Kirsty, the floor is yours. Thank you.
Thank you so much to all of our really distinguished speakers for joining us today as founders of the Flexible Nuclear Campaign. We're just delighted to be here with you. So as Ange said, I'd like to just step us through some of the key insights from our missing link to a livable climate report. First of all, I guess I don't need to repeat really the very strong message that we heard from Tanaka-san about the ongoing challenge of the hard-to-abate sectors, despite the real success that we are seeing and we hope will continue to see in renewables deployment and electrification and energy efficiency. We still see a very tough to decarbonize sectors continuing to dominate the energy system well into mid-century, according to forecasts such as this that we see here from the IEA, very consistent with mainstream energy systems forecasts. And what we're really looking at here actually is a 3 to 4 degree warming trajectory, really far from the 1.5 to 2 degrees Paris goals. So if we are to achieve those 1.5 to 2 degree Paris goals, this chart really illustrates just how much we have to do a very steep emissions reduction curve to mid-century within incredibly challenging timescales, 29 years to 2050. And then beyond that, we need hundreds of gigawatts more energy production in order to extract carbon from the atmosphere in the second half of this century, all whilst growing the energy system to supply the developing world. So given this challenging scale and timescales, our hypothesis is that we need drop-in substitutes that are really comparable in terms of cost and performance to replace fossil fuels that enable us to repurpose as much as possible our existing storage, transport, and end-use infrastructure without emissions, whilst also leveraging existing skills and supply chain to achieve this cost and scale of the transition that is needed. So just like an Impossible Burger, in fact, which is a highly scalable plant-based meat substitute that doesn't depend on behavior change, nor on people being willing to pay more. So let's look at some impossible burgers for decarbonizing the hard-to-abate sectors, and in particular looking at liquid fuels. So drop-in substitutes like ammonia or synthetic hydrocarbons should be comparable, first of all, to the oil prices that we're used to paying today. And hydrogen is a really key ingredient in the production of those synthetic fuels. So the clean hydrogen also needs to be really, really cheap. In fact, less than $1.50 for ammonia production and less than $1 for synthetic hydrocarbons if we're to be within the range of oil prices that we're used to paying today. Now, it's possible to achieve these really low costs with high temperature heat sources delivered in a refinery scale hydrogen and synthetic fuels gigafactory, like you see here today. This is a fully integrated installation, manufacturing and production facility, which is hosting 36 high temperature heat sources that are manufactured in the grey sheds there at the back of the facility, installed and producing hydrogen for less than $1 a kilogram. And we modeled the hydrogen gigafactory into the UK's Energy Systems Catapult energy system model. And you can see here the effect when you can supply carbon neutral synthetic fuels at the same price or potentially even lower than the fossil fuel version today, a really rapid switch. And the reason for this is that the synthetic jet fuel is equivalent to the jet fuel price that we're used to paying today, in contrast with the dark green box that you see on the chart here, which is the biofuel alternative that that's being explored and is forecast not only to cost 3 times or more the costs that we're used to paying today, but actually is really problematic as well to scale if we're serious about accommodating global demand for travel. Now, the second way to deliver really low-cost fuels production without emissions is to move into a really high productivity manufacturing environment, such as a world-class shipyard, which you can see here, where the products are designed to maximize the benefits of modular construction and assembly in a really highly efficient and very modern factory environment. In fact, world-class shipyards already work very closely with the oil and gas sectors to produce large offshore production facilities, such as you can see here, in this case using high temperature heat sources to produce hydrogen and ammonia for the shipping industry. So this is really leveraging world-class existing shipyard manufacturing capability, as well as oil and gas production, storage, distribution, and end-use infrastructure without emissions. This is a multi-product platform envisaged to be moored off the coast of a developing country, maybe like Ghana, for example, making hydrogen, power, ammonia for diesel engines and combined cycle gas turbines, whilst also using the waste heat to desalinate enough water for the entire city region of Accra. Really an incredible sort of multi-product infrastructure project without requiring all of those terrestrial projects to be built on land. So the evolution of costs that we're used to seeing from recent first of a kind, first in a generation nuclear construction projects in the United States and Europe, the evolution of cost reduction is achievable firstly by moving to a programmatic approach, such as we've seen previously in the US and in Japan, for example, with the cost reduction shown in light green, and then ultimately away from project-based approaches to product-based high manufacturing and mass production environments, such as those examples that I just showed you. And the result is that we should be able to substitute the planned flow of oil and gas over the next 3 decades for a smaller investment, just $18 trillion, than the oil and gas industry intends to spend anyway in order to maintain the flow of oil and gas. Approximately $24 trillion is forecast to be spent. As my 9-year-old put it, you mean it would be cheaper to save the world than to destroy it? And then finally, when we're thinking about decarbonizing other sectors beyond electricity, it's really important to consider the space that will be required for alternative fuels production. This slide shows the area that would be required to replace the UK or Japan's current oil consumption with hydrogen produced either from offshore wind, shown in the pink, with solar, shown in yellow, or with the gigafactory style or shipyard manufactured production platform option, which is shown there in the small green dot with the arrow pointing at it, really sort of demonstrating that this approach need not compete with our existing renewables deployment strategies for the decarbonization of electricity, but that actually we could really integrate our strategies between nuclear and renewables and achieve our goal, which is net zero by 2050. Thank you so much.
Kirsty, thank you very much. I wish we had more time to go this into detail, but we invite the audience to really check out this report Kirsty mentioned on the Terra Praxis website, and I think it's a must read. On that, I would like to introduce Rita Burnwell. Rita is the Vice President of Nuclear and Chief Nuclear Officer at EPRI. Rita, the floor is yours. Thank you.
Great. Thank you for the introduction, and it is my pleasure to be here with you today. Touching on what Kirsty said, the problem statement is that we have heavy transportation that is very difficult, heavy transportation sector that's very difficult to decarbonize, and also potable water, which is really the next oil of the 21st century. And so those two areas are a place where advanced nuclear really can play a key role. And EPRI's role in the development and deployment of advanced nuclear technology is part of our mission. We seek to identify, understand, and enable commercialization of advanced technologies that are affordable, reliable, and environmentally responsible. And I want to talk a little bit about marine shipping, and it conveys 90% of global trade and is certainly one of the most difficult industry sectors to decarbonize. Some of the other heavy haul modes that are also difficult to decarbonize are long haul trucking and commercial aviation, both passenger commercial aviation and cargo aviation. So EPRI embarked on a study and really evaluated a few different scenarios. And the premise was that achieving global decarbonization targets while maintaining or even increasing access to clean, reliable energy requires deployment of carbon neutral technologies at scales that point to new thinking and revolutionary new deployment models. And so some of the areas that were explored were fabricating the entire standardized nuclear plant in a shipyard, delivering the plant to the point of use via ocean, and producing high value storage, conveyable commodities for large established markets on a like for like basis, if that's possible. So what supports this scenario, this premise, is actually not very revolutionary. Ships are already built this way. We have 7 decades of nuclear naval propulsion to point to as exemplary scenarios of where this can be done. The petroleum industry has moved to floating production, storage, and offloading platforms known as FPSOs. And floating nuclear power plants for commercial grids are being developed, deployed, and operated. And so EPRI assessed 4 different scenarios. And while I don't have the time to go over all of those here, I can give you a little teaser that the report will be available soon and is entitled Non-Electric Applications for Advanced High Temperature Reactors, Future Deployment Scenarios for High Penetration and Deep Decarbonization of Non-Electricity Energy Markets. But the upshot of that work is that the delivery model can radically change cost and commercial business cases. They can determine and enable scalability. New technologies are not needed for these scenarios, but new technologies can certainly improve them. And then the market pull from any one of these 4 scenarios could provide demand, investment, and access to capital that's needed to establish fundamentally new plant design, manufacturing, and delivery models, enable deployment at scales needed for economy of numbers from high volume manufacturing, and enable deployment at scales relevant for global climate change mitigation. Thanks for your attention.
Rita, thank you very much. We very much look forward to that report, reading that report soon. Our next speaker is Yasushi Fukuzumi. Fukuzumi-san is the Executive Officer and a Senior Executive Fellow and Vice President of Energy Systems at Mitsubishi Heavy Industries. So it's my pleasure to introduce him, and the floor is yours.
Yes, thank you very much. First of all, thank you for your kind invitation. And I'm very delighted to be here with the distinguished panel's speakers today. So as a quick introduction myself, and then also our company, I'm just showing this slide. This is a conceptual image, how to achieve the carbon neutral society in year of 2050. Just before Prime Minister Suga announced that the Japanese long-term vision to achieve that carbon neutral society in year of 2050, we MHI also announced that our own MHI future stream, which is based on that renewable generated hydrogen and the energy efficiency, and then this is showing that the both 2 pathways. One is that the CO2 reduction, the other one is the CO2 recovery, which is the carbon capture or recycling, the utilization of the CO2. And we have some technologies that to contribute to this movement, like hydrogen burning gas turbine, carbon capture system, energy efficiency, of course, at the renewable energy. I did not include the nuclear technology here, but nuclear topics in Japan is little bit sensitive, so we didn't include that, but we are seriously working on the nuclear technology. Conventional technology, as well as the advanced nuclear systems like high temperature gas reactors and so on. Okay, next page, please. Our discussion of the green hydrogen or blue hydrogen, green ammonia, blue ammonia has been started initially from the viewpoint of the power generation, whereas the renewable energy is sometimes very surplus and a negative price. Or why don't we utilize that, the renewable energy for storing the energy and then, making that clean, generation. But as we are going through those studies, we came to know that we have to really focus on the industry. This graph shows that the Bloomberg New Energy Finance Energy Outlook 2020. It shows that there will be a decrease in the CO2 emission in the power sector. However, there will be increasing of the CO2 emission keep on going up in the industry. And then because that we've been involved ourselves to that industry, business, as we supply that so many machineries to them, we came to know that the importance of that industry is CO2 emission reduction. And at the same time, that carbon neutral fuel investment are kind of little bit difficult to recover that the only by power generation. That's why we are currently focusing on that. The right hand side shows that our new generation steel making process, HIFO, our group company Primetals is now working on the hydrogen-based steel making process. As such that we are trying to develop that hydrogen usage among the industries. That's our current focus right now. Next page, please. So for that purpose, that we are investing ourselves to that the venture company in the South Australia, where that the renewable energy resources are quite rich. And then there that we are making the green hydrogen as well as the green ammonia. And then the hydrogen will be used not only for the power generation, but also for the local industry, for contributing to their chemical industry, fertilizer industry, also shipping fuel as well. And then the site is just adjacent to the local steel making company. As such that we are trying to also develop the consumption side of the green ammonia or green hydrogen, as we see that the initial takeoff of those green carbon neutral fuel might be probably starting from the industry side as well. So next page, please. As one of the activity is we are participating as a foundation partner to the AP Moller Maersk established institute, which is called Zero Carbon Shipping Institute. This is led by that AP Moller Maersk, who is the market leader for the ocean freight company. And then they are seeking for that the carbon neutral, finally achieved in 2050 for the shipping industry. The bottom left in the graph shows that the CO2 emissions from the shipping industry. Left one is that IMO target case, and the right-hand side is a very aggressive, graph to show that the carbon almost zero emission from the shipping industry. How to do that? we are working on the upstream, fuel development side, as well as the onboard, equipment and innovation side. So for that purpose, that the AP Moller Maersk is inviting many strategic partners, including us, as well as the stakeholders that various supply chains, whole supply chain of the green fuel. So this activity has been started, and then the little bit slowed down because of the COVID-19. But now that this is accelerated, and then the many players now participating to contribute to this, the institute activity. The concept is, 1, 2, 3, 4, like building consensus, knowledge share, and address the gaps, and then also influencing to that, the public sector. So I think, this is the ideal case for any type of the carbon neutral business, not only just the shipping. Anyway, we are quite excited about this activity. Thank you for your listening. That's all.
Fukuzume-san, thank you very much. That was great. I would like to now invite Carlos Lepner. Carlos is a Director of Global Nuclear Energy Strategy at Clean Energy Task Force. And I'd like to also highlight that in his previous work, Carlos was serving as the Vice President for both Westinghouse and Framatome. Carlos, the floor is yours. Thank you.
So thank you again for the invitation. And I'm honored and delighted to be part of and to contribute to this important dialogue today. As you mentioned, although I spent most of my professional career in the nuclear commercial industry, I recently joined Clean Air Task Force, a leading global nonprofit organization that focuses on decarbonization of the energy sector because of the importance and urgency of the environmental challenges that we're all facing today due to climate change impacts. We think for 25 years, CATF has pushed change in technologies and policies needed to get to a zero emissions, high energy planet at an affordable cost. We think the challenge with climate change is so huge that we need to consider every tool in our toolbox. Now, we already have part of that solution with renewables like solar and wind power, but this is the biggest bet we'll ever make on our planet. So are we really going to put all our chips on a couple of options? We think this is a too risky of an approach. Hence, we're not afraid to examine all options with an open mind. For example, we're realistic about fossil fuel in that they will be with us in the foreseeable future. So we work a lot on technologies that can remove carbon from fossil fuel and from the air. We also look at deep geothermal technologies as well as zero carbon fuels. Then a decade ago, CATF took a harder look at nuclear energy and realized that there are designs and nuclear technologies that are safer and less expensive. In 2018, CATF issued a report that explores how a massive scale up in the production and use of zero carbon hydrogen and ammonia might decarbonize segments of the energy sector, particularly the transportation sector, as we're discussing today. Hydrogen and ammonia can be produced and converted into energy through processes that emit zero greenhouse gases. The production of these chemicals can be massively scalable, and they're highly flexible as energy products. They can be produced and used in a variety of ways. They also can play an important role in addressing several decarbonization challenges, such as storing excess power produced by variable renewable energy sources like wind and solar. They can be used to ramp down the carbon intensity of the energy produced by existing power plants. They can reduce the carbon content of natural gas through blending. And they can safely and efficiently transport hydrogen. I encourage you to look up this report for more details. So why consider nuclear technology to produce zero carbon fuels? First, we can see that existing nuclear reactors today operate with great performance, typically with capacity factors above 90%. They're very reliable. They have an established, proven operating experience. They are clean as they don't emit CO2 as part of their operations. They also can offer flexible pathways to produce hydrogen, which then can be used for many purposes. Hydrogen can be produced from nuclear power via low or high temperature electrolysis, as well as via a thermochemical process. Today, there are already several nuclear hydrogen programs being developed. In the United States, for example, there are demonstrations with 1 to 2 megawatt electrolyzers planned at existing LWRs for low temperature electrolysis prototypes. In France, EDF is planning hydrogen production with its nuclear fleet. Even in Brazil, Electronuclear is already producing hydrogen as a byproduct from a local chemical process and is considering a project to capture the hydrogen and use it for various applications. So the development is real. But with new nuclear technology, the advanced reactors are changing paradigms. New reactor designs, including many small modular reactors, SMRs, high temperature gas reactors, molten salt, or other high temperature design like heat pipes, are being developed, and a few are about to be deployed this decade. These advanced designs offer multiple applications, not just for power generation, but also for non-electric applications such as desalination, hydrogen production, process heat, and others. These advanced designs offer many favorable features. First, using an advanced manufacturing approach, as have been mentioned by Rita and Kirsty, a shipyard model, will dramatically reduce cost, reduce construction time, and increase quality. These have improved safety, inherent safety. They can walk away safe type of designs. And they're modular and scalable in size and deployment, which translates into reduced CapEx and OpEx. Clean Air Task Force is leading a nuclear hydrogen initiative with several working groups focusing on policy, technology and licensing, markets and partnerships, and financing in order to craft actions and recommendations to move forward in a meaningful way in these initiatives. In closing, we are all challenged by the climate change impacts and the aggressive mitigating goals that are ahead of us. Achieving zero by 2050 is not an easy task, and we believe that we need to look at and use all the available options at our disposal. Decarbonizing the energy matrix is hard, and even harder in certain sectors like transportation and shipping, as we are discussing. A transition to zero carbon fuels is key, and both hydrogen and ammonia will be essential to enable this change. Nuclear energy and advanced reactors will also play an important role in this journey due to their high energy density, reliable performance, scalability, and zero carbon emissions characteristics. It's a tool in our energy toolbox that should not be spared. Once again, thank you for the opportunity to share these perspectives.
Carlos, thank you very much. I think the message could not have been clear that all hands on deck when it comes to all the available technologies to reach those rather important goals by 2050. I would like to now introduce Eri Nakatani. Nakatani-san is the Deputy Director of Nuclear Energy Policy at METI. Nakatani-san, the floor is yours. Thank you.
Thank you very much. My name is Eri Nakatani at the Ministry of Economy, Trade and Industry of Japan. Very nice to meet you. We believe nuclear innovation can contribute to decarbonizing the world in many aspects. Of course, we as government of Japan put safety first when we think about nuclear because of all the lessons learned from TEPCO Fukushima Daiichi accident. But it can also address issues related to renewable energy age, such as flexibility and multipurpose use. It may also contribute to higher economic efficiency, as well as addressing nuclear-specific issues such as non-proliferation and radioactive waste. As Tanaka-san noted, the government of Japan published the Green Growth Strategy at the end of last year, and it highlights, oh, sorry, please go to the next slide. So the government of Japan published the Green Growth Strategy at the end of last year, and it highlights nuclear as well as hydrogen. Next slide, please. Among nuclear innovation technologies, I would like to especially highlight high temperature gas-cooled reactor and fusion reactor for this event. Both have the great potential to efficiently utilize high temperature heat, which is necessary for decarbonizing hard-to-abate sectors, such as steel, chemicals, etc. Next slide, please. My ministry, Ministry of Economy, Trade and Industry of Japan, as well as Ministry of Science, together with national lab JAEA, have been promoting nuclear innovation program called NEXIP. Our national lab, JAEA, can provide R&D facilities and resources, and together with these stakeholders, we are supporting several feasibility studies by private companies. We believe innovation programs such as this is the best, not only the best innovation policy, but also the best human resources development policy. Next slide, please. This slide shows the example of HTGR. High temperature gas cooled reactor can provide flexible power utilizing its high temperature heat. When the grid does not need electricity, such as when the sun is shining and wind is blowing enough, we can utilize the heat to produce hydrogen, which is another form of energy storage. And it has a superior inherent safety nature, since HTGR shuts down and cools down without any equipment or operator action. Next slide, please. Japan already has an experimental HTGR called HTTR, and it has a historical record of achieving 50 days of continuous operation at 950 degrees Celsius, which is the first in the world. Next slide, please. In the NEXIP program, our ministry is supporting 2 feasibility studies of HTGR. One is done by Mitsubishi Heavy Industry, hydrogen and electricity cogeneration HTGR. The other is conducted by Toshiba ESS and Fuji Electric. They are working on heat storage HTGR, coupled with molten salt heat storage system. And we are also supporting a nuclear fusion company called Kyoto Fusioneering. Since nuclear fusion needs components which can withstand high temperature, we believe Japanese industrial base can contribute to the world, especially when many venture companies in the West are working on nuclear fusion reactors. So thank you very much for your attention. We hope Japan can contribute to decarbonization utilizing nuclear heat.
Thank you, Nakatani-san. It was a great presentation. I believe it's been a great round of statements to begin with, and there are some questions I may ask, beginning with a quick statement that, you know, we need 100 times scale up in less than 30 years to meet this challenge. We need a very large market to achieve the scale, but we also need to create purchasing mechanisms where every single ammonia project, for example, can achieve the target cost or below, which is contracted to do so. Do we see the evidence of any of these coming along at this stage? So I open the floor, so please, anybody who would like to pick that up.
I think to date, the climate and energy discourse has been, you know, understandably largely focused on the electricity sector. And that's important because there's a lot of opportunities there to decarbonize and also to expand electrification into other sectors to support that decarbonization. But as we've heard today, there are a lot of, you know, hard to abate, unsolved parts of the challenge that do need to be addressed in other ways. And, you know, that's, I think, now what's becoming more of a priority. We're looking for new production options. Go to Rita and Seth.
To start answering your question, what are we seeing today? The Department of Energy in the United States is funding 3 pilot projects to generate hydrogen from existing nuclear power plants via low temperature electrolysis at first, and then moving to high temperature electrolysis. And I think this is it's a step in the right direction to demonstrate using nuclear power plants for non-electric applications, as well as creating additional revenue streams for existing power plants. And certainly we can use these examples to build off and deploy new fuel concepts, new, for example, use the technology to desalinate water as well. But I think seeing the demonstration at these plants in these pilot projects is really key, and it's very exciting at the moment.
Thank you. Seth, would you like to jump in?
I felt for many years that the world would not meet climate goals, that we will find out what it's like to live in a world with average temperatures increased more than 2 degrees C. The hard to decarbonize sectors such as aviation and shipping are just too hard to decarbonize cheaply enough at global scale. When I read the Missing Link report, I thought for the first time they had found an approach that could work. And I very much want to commend in particular Rita's work at DOE for really, truly making a difference and setting the stage for bringing forward technologies that really might work in time. I really haven't seen an effort like this before. So I want to thank Kirsty and her colleagues, particularly Eric Ingersoll, and in particular Rita, who on the ground have really brought things forward that bring hope.
Thank you very much. Kirsty, would you like to respond to that?
Oh, I'm just feeling bashful. That's really kind of you to set up. And I agree with you about Rita's incredible efforts. But Tanaka-san, I think you're ready.
Yeah, well, thank you very much. I mean, and the question is that, is it really happening? Well, I think Japan has started talking about hydrogen some time ago, but we are not really moving ahead quickly enough about this hydrogen fuel cell vehicle refueling station deployment. And in fact, China has overtook us, and now the Europe overtook and moving much, much faster by huge investment. So about hydrogen, the thing is, when Japan is really starting talking about hydrogen, nobody dances with us. But with China starting dancing, everybody starts dancing together. So Europe is moving ahead because of abundant renewables should be utilized by storage of hydrogen and using it in gas, etc. So this hydrogen strategy is more or less, of course, sustainable strategy, but national security or energy security policy for China to get more renewables usable is reducing oil and gas dependency to the Middle East and from Russia or from the United States. So Europe, the same thing. Energy security, if we think about energy security, using hydrogen as a storage is a really meaningful way. So renewable is abundant everywhere. Chile will be a very important security, let's say, provider in the future if the trading of ammonia or blue hydrogen is taking place. Japan is trying to, replace liquid natural gas to liquid hydrogen or liquid ammonia or chemical hydrate and help Asian developing countries to decarbonize hard-to-abate sectors like coal power, etc. Mixing hydrogen with coal is a very easy way to reduce carbon dioxide in these countries. So Japanese idea is, okay, let's make a big supply chain of hydrogen around the world of connecting players together and try to reduce, because Japanese reduction is not a big deal, but if we engage emerging Asia or growing Asia, the impact is much, much more significant.
Thank you. Dr. Platt, yeah, thank you.
Yes, may I just put your attention in a project that we're doing down in Patagonia. We're putting the Patagonia wind into synthetic fuels. The project is of course, it's now starting. It will start production in March next year. It's called HIF, Highly Innovative Fuels. And what we will do is pack the wind into a bottle and making green hydrogen, methanol, and gasoline. And that is on a big scale. We have had even help from the German government. We do have a fund. So pay attention to that, because it's important that this will be on the gigawatt scale. It's very interesting because, of course, there we have wind with 70% plant factor, which is crazy. Because we have very high winds, 11 meters per second, and very constant all around the year. So this will be a decarbonizing of a lot. We calculate in 4 or 5 years, we will be can have zero emission fuel for all Chile, or 14% of Germany's fuel consumption. So it's quite a lot. So we will continue in that effort to scale up these technologies on a scale which worldwide hasn't been done. And we are very proud of this kind of projects that I hope you can come and visit us.
Thank you. Carlos, I think you wanted to come in.
Yeah, I just want to agree with the sentiment that I'm hopeful also of this new opportunity that is before us to solve this very important problem. But I think we still need to address specifically about the nuclear technology and nuclear industry. It's a chicken and egg situation too. We need to develop the markets, right? I mean, there's a great potential for hydrogen and ammonia markets, but that will require different business models to deploy nuclear as well to meet that demand. So I think how to address the challenges the nuclear industry faces today, it's still a lot of work to be done in a short amount of time, and we can get into that if you like.
Thank you. I think, as you said, you talked about the markets itself, so I will ask Fukusumi-san, working in the private sector, I mean, how would we scale up these markets?
So I think, we are somehow living in a democratic world, and the meaning that we somehow need to work on that some economic principle or that the market competition. So we think that the real market takeoff may start with the low cost, application, meaning that the Armin-san's, country Chile has that, the rich renewable resources. So the one project where we invested is the South Australia, also the similar, situation. So the renewable, generation electricity is very low, cost is very low, like less than Australian $30 per megawatt hour, which makes the less than $3 per kg hydrogen. And on paper, we are working on the somehow $600 or $700 dollars per ton ammonia right now. Our target is, of course, at the $400, but the choosing that some of the possible promising location, and then they do the actual, feasibility study as well as the feed activity, which we are currently doing, involve ourselves and also deploying that our hydrogen compressors and storage, without having the real demonstration that we really cannot know that whether that price level is nearly coming to the real. And then maybe with the slight subsidies, we can maybe achieve that, the actual commercial, scale, the production. But our approach is starting from the actual practical case, which may be the low cost renewable generation first, and then takes off that the market, or green ammonia, green hydrogen ammonia, then probably working on more economical way of producing the hydrogen by centralized, more dense energy, methodology, which will be nuclear anyway. But to overcome that hurdle of that new nuclear, the station, that we have to somehow show that the actual proof of concept by realizing that actual project, first of all, with the renewable energy. That's our strategy currently right now.
Thank you very much, Fukusumi-san. Nagatani-san, I'd like to bring you into this. So one side is the markets, investments, and the other side is the regulation. So how do we make sure that regulation is also catching up and evolving fast to get to this goal we need to get to very quickly?
Thank you very much. I think that's a very good question. So when it comes to deploying hydrogen to the market, especially hydrogen produced from nuclear, we think that addressing regulatory issues is very important. So we think that we need to first of all excavate the condition for producing hydrogen in next to nuclear facility. So that's the first one step, and that also needs R&D as well when it comes to producing hydrogen next to nuclear facility. So we will actually establish necessary technologies by 2030 to produce hydrogen in the vicinity of a nuclear facility. And then we can really scale the nuclear hydrogen, especially utilizing HDGR and so on.
Thank you. Kirsty, I believe you would like to jump into that.
Yeah, this is great because, you know, really to meet these very ambitious timescales and the scale of the challenge, we need to move forward on all fronts. And what we're hearing from Chile, from Japan, from the US, from the UK, that, you know, we're seeing like real progress moving forward on all fronts. And in particular, it's really important to remember that there will be a lot of, you know, transfer of knowledge and technology development across all of these different technologies. So all of this innovation that we're seeing, you know, is the rising tide that lifts all the boats ultimately. I thought that Carlos made a really good point about, you know, the need for a sort of paradigm shift in the nuclear industry. You know, we've seen really successful cost reduction and increased rates of deployment in wind and solar, and there's really an opportunity for us to learn from that success and apply much of that learning, not only in terms of technology development and improved efficiency and performance of the technology, but also access to finance and, you know, procurement and policy interventions and so on that supports that innovation, commercialization, and ultimately large-scale deployment. The really interesting thing, just finally to say about the opportunity for high temperature heat sources, nuclear technologies to produce commodities to make liquid fuels like ammonia or synthetic hydrocarbons, is it's really different from the utilities-based model that we've traditionally seen in the nuclear sector. It allows you, first of all, a lot more flexibility in terms of where you site your facilities. If you have a gigafactory refinery scale facility, for example, you can locate that where it's appropriate, where it's convenient for you to do so, rather than being tied to the electricity sector and the transmission requirements. And it also allows you to deliver a scale for your product, for your project, because you're producing commodities that can be stored and transported and exported to global markets. So that's a really different business proposition for the sector and enables real investment to be made in the manufacturing facilities to really deliver those very low costs and that very large scale. So I think that there really is an opportunity here to achieve that paradigm shift that Carlos is very, you know, correctly identifying as being needed.
Kirsty, thank you. I think we've got probably 3 minutes left, but I would like to bring Rita into this conversation around the role of financial markets. So we talked about investments and we need to scale up. The one side is regulation, the other side is the financial side. Obviously, governments can't solve everything themselves. So what role do you see of the financial sector and how that can be expedited?
I think we really need to be paying attention to the private investment financial side of things. Angel investors, philanthropic interests. There's a lot of potential funding out there, and it's looking for clean energy investments. And that's exactly what we're talking about. Not only clean energy, but clean energy taking the place of fossil. And so I think us as an industry actively engaging with those types of investors, potential investors, is very important. And then also certainly, continuing to work with the large global entities. In the United States, Development Finance Corporation recently reversed its posture on deploying new nuclear, so that's really good news. World Bank is still not there yet, but I think given the crisis that we do have globally with climate change, I am optimistic that posture might change. But certainly, and I think we go back to Carlos's point as well, we need to do a better job of marketing our technology and talking about it as a tool to help with this crisis at the moment.
Carlos, would you like to add anything before we end?
Yeah, I think we hit all the high marks. I think there's a great potential for nuclear again to play an important role in the decarbonization of these very hard to abate sectors in transportation and shipping. So I think the challenge is before us, and we just need to work together to figure out a solution, because the planet is not waiting for us. So we need to act on it.
Thank you very much. On that note, I would like to end our great session. So I'd like to thank you all for participating here. It's been a true pleasure sharing this side event with yourself. I would like to extend a special thanks to our organizers, Terra Praxis, Third Way, ClearPath, and Nice Future Initiative for gathering such a great and distinguished panel. I would like to wish you a nice day and look forward to an excellent series of clean energy ministerial events this week. Thank you very much.